Now, let us see a situation where we have a mirror which is like this, and there is an object which is placed over here. Now, think of this case and tell me, will that mirror form an image for this object or not? So, if the object is here, this is the mirror. So, will the mirror form an image for this particular object? So, at the first look it might feel like the image will not be formed, but that is not actually correct. The image will be formed, and the image will be formed exactly in the same scenario as how the image would be formed if the mirror was completely present throughout this region. So, if the mirror was completely present, the location where the image would be formed will also be the image in this particular scenario. And the reason is something like this. You can draw a light ray in this manner, or you can take two light rays and you can then reflect them from the mirror. And if you once again retrace them backwards, these are the reflected rays. If you retrace them backwards to find where they intersect, you would observe that they intersect exactly at the point which we find by drawing these perpendicular distances. So, if I just extend the mirror, you would once again see that this length and this length will be equal to each other. So, in each and every case, whether the mirror is directly in front of the object or it is above, slightly away from the object, you can always use this method to find the location of the image. So, all you will have to do is, if the mirror is not completely present, just assume that it is extended in this manner, drop a perpendicular and draw the same distance on the other side, and that would be the location of the image. So, this is where the image is formed. Now, when you compare that with this case where we have a mirror which is long and the object is placed over here, similar distance, the distance is same in this case when compared with this. Now, once again the image is formed at the same distance behind the mirror. So, there is no change in the position of the image formed. So, whether the mirror is a small mirror which is placed over here or a large mirror which is covering a large distance, the image of this object will always be formed at this particular position. Okay. So, that is something which we have understood. So, what I am trying to say here is that in this case of this long mirror, if the image is formed over here, even if I cut some part of this mirror, let us say I have cut this whole part and I have just left this part. So, even in that case the image will be formed here itself. So, the location of the image is not going to change. So, that is what I said, even if I cut this whole part and have only this part, it is similar to this case. The image will still be formed at the same position. Okay. Now, but there should be some sort of difference between the two cases, right? Otherwise, I can just cut off the mirror and just use a small mirror each and every time. So, whenever we are using mirrors, why are we using long mirrors? Why can't we just use small mirrors when even small mirrors can produce the same image? And the reason is, in this case if you observe, the image which is formed, let us say there is a person who is viewing it from here. So, if a person is viewing it from here, so because the area of the mirror here is very large, so it is able to collect large number of light rays coming from the object. So, this mirror will be able to receive more light rays from the object and in the process reflect more light rays backwards. So, more number of light rays will be coming from the mirror in this case. So, which means for a person who is viewing it from here, he receives more light rays. So, he receives more light rays and he thinks that all those light rays, because they appear to come from this point, because he is receiving more light rays, he thinks that the image is more brighter. So, that is what happens in this case. So, when we have a larger mirror, we can say that the brightness is more. If you are able to collect all these light rays into your eye, you will definitely see that the brightness is more. But in this case, if you see, even though you can receive, let us say you can receive even more rays, but because the mirror's size is very small, you would receive less number of light rays, and in that scenario you will see that the image has lesser brightness. And the second thing which we will have to keep in mind is that, which is an advantage in this particular scenario, is called as field of view. This is a very important concept. So, let us understand what field of view is. So, Field of view basically means the region from which the image can be observed. So, as simple as that, field of view means the region from which an image can be observed. Okay. So, in this particular case, if you see, to understand the field of view, the idea is pretty simple. If let us say this is the mirror, all I will have to do is draw the extreme rays onto that mirror. So, extreme rays basically means the rays from the object striking the ends of the mirror. So, if the mirror is of this much size, so these two light rays will automatically become the extreme rays of that mirror. So, what I can say is each and every light ray which is starting from the object and striking the mirror will strike in this region and will definitely move between these two extreme reflected rays. So, they will definitely have to travel between these two itself, right. So, what that means is, if there is a person who is trying to look at this image, he is trying to look at where the image of this object is formed, let us say, and if he stands here with his eye line in this manner, so will this person be able to see this image? No. The reason is, he is not receiving any light rays from the image. So, we know that image is basically the perception of where the light rays appear to come from. Now, according to him, he is not receiving any light rays coming from the mirror. So, he can't see that image, he can't see the image of this particular object in the mirror. So, which the reason for that is because this person, he is not present in the region where the light rays are travelling, and the region where the light rays are travelling is what we call as the field of view. So, we say that in this particular case, let us call this as person A, and there is another person, let us say he is over here and seeing in this direction, and if this is person B, so we can say that only B can observe the image I. So, this image can be observed only by this person B and not A, because A is not in the field of view of this particular image. So, that is the basic idea. So, whenever you need to find the field of view, all you have to do is draw the extreme rays from the object, reflect them, and whatever is the region which is formed between those two reflected rays, so that region is what we call as field of view. Or another simple method for drawing field of view, which I will show you in this particular case, I will take a very slightly smaller mirror, taking this much bigger mirror will make the field of view go out of the board. So, I will make it little bit smaller. Okay. So, let us consider that the mirror is like this. So, just like this, I can take the extreme rays from the object onto the mirror, extend them backwards, or another simple method is first locate the image like we have already done here. So, first locate the image, so which is this, and then from the image draw the extreme lines to the edges of the mirror and then draw them backwards. So, this is exactly what would be the extreme rays if you would have drawn light rays incident from the object. So, if you would have taken two incident light rays from the object and if you reflect them back from the mirror, so this exactly would be the light rays. So, instead of drawing the light rays from the object and reflecting them back, first find the location of the image and then draw a line from the image through the edges of the mirror. So, we can say that this whole region which is formed over here, so this whole region will be the field of view. Let us call this as I dash, field of view of I dash. So, you can clearly see that because of changing the position of the mirror or taking a slightly larger mirror, the field of view has become larger. So, in this case the field of view is pretty small. So, this is the field of view from which the image can be observed, and in this case the field of view is larger because we have taken a larger mirror, plus we have also changed the position of the mirror. So, keep in mind, so to find the field of view, all you will have to do is first find the image location and draw the extreme lines passing through the edges of the mirror, and that region which is formed will give you the field of view. So, we will see some examples based on field of view now. So, let us solve a question now. So, here it is given that the length of the mirror is L, there is an object which is placed in front of the mirror, and a man M is walking along the path and looks into the mirror. Over how much length will he be able to observe the image of O? So, as this man is walking along this path in this direction, he is looking into the mirror which is over here at a distance of 4D from him, and he basically has to see the image of this object. So, the question here is, while he is walking, over how much length through that path will he be able to see the image formed? So, obviously, we are talking about field of view here, field of view of the image formed. So, if I just locate the image first, we know that we can draw a perpendicular line of distance d onto the other side. This length will also be d. So, this is where the image is formed, and we have just discussed earlier that for this image to be visible, we know that this image will be visible only from the field of view of the image, and to find the field of view of the image, all I will have to do is draw a line to the edge of the mirror and then extend that backwards on either side. So, we can say that so we can also understand this in this manner. So, these light rays are the extreme light rays which are coming from the object and falling on the mirror. So, only if the man is in this region between the blue lines, he will be able to receive light rays coming from the mirror. If he is, let us say, somewhere over here, no light ray will be able to reach this person who is standing over here coming from the mirror. He will not be able to receive the light rays from the mirror, which means he will not be able to see the object. So, which means they are asking us to find out this length from here till here. So, that is the length over which the man will be able to observe the mirror, the image in the mirror. So, let us call this I, let us call the mirror AB and these 2 points as CD. So, I will have to find the length of CD. I know the different lengths over here. So, you can clearly see that in this case, if you look at triangles IAB and triangle, this is the smaller triangle and this is the bigger triangle. If you look at these two, another one is ICD. So, IAB is this smaller triangle, this one, and ICD is this bigger triangle. So, we can say that those two are similar to each other, and the reason why they are similar to each other is because you can say that this angle is common for both, that is a common angle, and this line and this line are parallel, and this is the same line, which means this angle and this angle are also equal. By the same logic, I can say that this angle and this angle are also equal. So, they are similar triangles. Now, we know that in similar triangles, the ratio of all the distances should be equal. So, if I use that logic here, we can say that this length by this length, let me write it down, AB by CD should be equal to the height of this triangle divided by the height of the bigger triangle. I can write that. So, let me also extend this and let me name this as E and this as F. So, I can write this as AB by CD is equal to IF by IE, IF by IE. So, just substitute the values. We need to calculate the value of CD, that is what is being asked in the question. So, substitute all the remaining values. AB is the length of the mirror, which is given as L. So, I will be getting L by CD is equal to IF. IF is this length, which is D. So, D divided by IE. So, IE is this whole length, and how much is that? 3D D D, which is 5D. So, D and D gets cancelled and you will get CD is equal to 5L. That is the idea. Now, similarly, let us say we will see one more example. So, this time let us consider that there is a mirror over here. And this one here is a screen. So, let us consider that the width of that mirror is some L. So, L is the width of that mirror, and what I have done is I have placed a source of light, a point source of light, a bulb you can say. So, it is emitting light in all the directions. So, I have placed a light source over here. So, that is a light source. Okay. So, you know that this mirror will form the image of this light source behind the mirror. So, what I want you to do now is, if the length of the mirror is L, now think of this scenario like this: the light coming from this light source strikes the mirror and it reflects back onto the screen, and there is a bright spot which is formed on the screen. So, I guess you can understand that the light coming from here strikes the mirror and that light gets focused, or it falls onto the screen at some region. So, I want you to find out the width of the shadow, or the width of the spot, the light spot which is formed on the screen. So, once again this has something to do with the field of view, because if let us say the image of this is formed behind the mirror at the same distance, let me draw that. So, whatever is the perpendicular distance over here, we can say that at the same perpendicular distance the image will be formed behind. So, the image of this light source will be over here, image of light source. Okay. So, now when I draw any light ray, let me draw an extreme light ray here to one of the edges of the mirror. So, we know that this light ray will follow laws of reflection, and it just goes and reaches a point somewhere over here, and in such a way that this light ray which is getting reflected appears to come from a point which is behind, which is the image. So, what I can do here is, I can directly, just like in the earlier case we have done, I can just find out the field of view of the image. So, whatever is the image which is formed over here, I can just draw the field of view. So, I will just draw one more line to this edge and then I will extend it backwards. So, that is what I would get. Now, you can clearly see that this is the region on the screen where the light will come and strike. Or if the two extreme rays, let me also draw this line. Okay. So, from this light source I have drawn the extreme light rays and I have traced them onto the screen. So, these are the points between which the light rays would be falling. So, which means what I am asking you to find out is this width. So, let me write it down here. Find the width of the spot of light on the screen. Okay. So, as you can see, I could have directly taken two light rays and reflected them onto the screen, or I could have taken the image and drawn the extreme light rays passing through the edges to find the field of view of the image. So, whatever is the field of view of this image source, image will also be the region where the light will fall on the screen. So, once I have identified that, I will just find out this length, and for finding that length, once again I will use similar triangles. I will mark some names, terms here. Let me call this I, the mirror as AB, and the points on the screen as CD. And once again in this question we can easily say that they are similar triangles. The triangles IAB is similar to triangle, the bigger triangle which is formed ICD. So, ICD. Now, using this, we know the length of AB, we need to find the length of CD. So, the idea is once again the same. So, I will write AB by CD is equal to, so this length by this length is equal to, when you now once again look here, if you consider this triangle, we can easily say that this will be the height of the triangle, right. So, if I call this as some h, we can easily say that this will also be equal to h, because object distance and image distance from the mirror should be equal to each other. So, both are h. So, this h is the height of this triangle, and this complete height will be the height of the bigger triangle, which is ICD. So, what I can do here is AB by CD is equal to height of this smaller triangle by height of the bigger triangle, which if I write, I will get h by 2h. So, simplifying this will give me, I am trying to find the value of CD. So, CD is equal to 2 times AB, so which is 2L. So, 2L will be the width of the light spot which is formed on the screen. So, that is the basic idea. Okay, I will give you one question from this which I want you to analyze. You can draw a similar ray diagram or the field of view diagram and try to analyze this. I will leave it to you for understanding. So, if let us say this is x direction and this is y direction, if the question for you is, if the mirror is moved in y direction by some distance, let us call that distance as some d, what happens to the size of light spot? So, that is the first one, and the continuation of this is, will it move? Okay. So, think about this. I will discuss the answer for this in the next class. So, if this mirror which is present over here is moved, let us say either downwards or upwards, so what happens to the size of this light spot which is formed on the screen? Okay. So, continuing with the idea of field of view. So, what we are going to discuss now is a very standard example. You might have, some of you might have already seen this. So, let us consider that there is a mirror and there is a person who is standing in front of the mirror. So, let me represent that person with a straight line. So, let us say this is the person, and let us say this is the topmost point, which is the head of that person, and this is the foot of the person, and his eyes are slightly below his highest level. So, if I represent his eye level is somewhere over here. So, let us represent it as E. Now, we need to find out the minimum length of the mirror, minimum length of mirror required for a man to see his complete image. So, let us understand this. So, the man is over here and he is trying to look into the mirror and see his own image. Now, what I will do is I will first draw the image directly, and the image should be seen by this person, right. So, what I will do is, in this particular scenario, so whatever is the distance at which the man is in front of the mirror, at the same distance we know that H will have an image of H dash, E will have an image of E dash, and F will have an image of F dash at the same distance. So, I will first draw the image of that man over here. So, same height as well. So, this would be H dash, this would be E dash, and this would be F dash, the corresponding images. Now, the person eye level is over here. Now, if this person has to see the image, so we can say that light should be able to reach from every point of the image to this eye. So, that is what it means. So, if I am trying to see something, so the light should appear to come from that particular point to me. So, which means if the man whose eye level is here has to see his foot, which is having its image over here, a light should appear to come from f dash and reach E. So, let me draw that over here. So, a light ray should appear to come from f dash and it should reach E. I hope this diagram is clear. So, let me draw it clearly. So, a light ray should appear to come from f dash, a light ray which is reaching the man's eye in this direction. It should appear to come from f dash. So, only then this man will be able to see his foot. So, which means this light ray actually is coming from the foot, but he sees that, he should see that the light ray is appearing to come from f dash. So, that is the basic idea. Now, in the same way I can say that if the man has to see the head, topmost point of him, then a light ray should appear to come from h dash and reach his eye. So, if I draw that, so that would be something like this, right. So, once again this basically means that a light ray is starting from the head, it is striking the mirror over here and reflecting and reaching the eye. But according to this eye or according to the person, this light ray is coming from this particular point. So, that is the basic idea. So, instead of doing this reflection analysis, I have directly drawn the image, and from the extreme points of the image I am just taking the two light rays to be reaching the eye. Now, if you see here, this man can see the foot by using this light ray, by using the light ray which is over here. Now, if you see, will anything change if this part of the mirror is removed? Even if that mirror is not there, he can still see the foot, because a light ray which is coming from the foot will strike here and reach the eye. So, which basically means that the part which I have removed here, which was initially here, it is not required, right. So, that is just extra, and the same logic goes with this mirror as well. So, the only part of the mirror which is required for us to see the full image will be this part. So, the part which is over here. I hope this is clear. So, what I have basically drawn is, if you look at this, it is in a way called as field of view of the image according to the eye. So, this eye should be able to see the full image inside the mirror. So, you can just look at it from the two light rays which are over here. So, these two light rays should appear to come from both the ends of that particular image. Only then this eye will be able to see that particular image. Okay. So, all we will have to do now is find the length of this particular mirror. We know that if the man's height is h, then the image height will also be equal to h. Now, once again look at the triangles which are formed over here. Let me name these two ends of the mirror required as A and B. So, I will just take the triangle over here. I will take triangle EAB, and the next one is triangle EH dash F dash, triangle EH dash F dash. So, now when you look at these two triangles, so once again they are similar. So, we have seen many cases like this. Once again they are similar, this angle is common for both, and we can say that this angle and this angle are same. Similarly, this angle and this angle are also same. So, they are similar triangles. So, I will just take the ratio of sides, this length AB by this length H dash F dash, AB by H dash F dash is equal to, here we can write, for this triangle EAB, this is the height of the triangle, which is D. So, D is the height of the triangle. So, D divided by, for this triangle the bigger one. So, for this bigger triangle we can say that this complete length will be the height of the triangle, which is 2D. So 2D. So D and D gets cancelled. We need to find the value of AB. So the value of AB will be equal to the value of h dash f dash is nothing but the height of the person, which is h by 2. So this is an important result as well. So for that person to be able to see his complete image in the mirror, the minimum length of the mirror that is required will be equal to h by 2. So that is the basic idea. Now I want you to use a similar concept and try a question which I am going to give you now. So keep in mind that what you have to do is first take the image directly, draw the image directly, and from the extremes of the image draw two lines to find out what is the length of the image that is required. So use the same concept and try to find this. So let us say there is a mirror like this, and there is a person who is standing over here, or let us say there is a boy who is standing over here, a young kid, he is standing over here and his father is standing over here, he is having a larger height. So let us say the eye level of the boy is at a distance of some 0.8 meters from ground. So let us consider that this length is 0.8 meters. So the eye level of the person, of the boy, this is boy and this is the father. So his height is 0.8 meters and the complete length or the height of the father is, let us say, 2 meters. Clear? So let us consider a scenario like this, and let us also consider that the boy is at some distance of 1 meter from the mirror and father is at a distance of 3 meters from the mirror. Okay, so let us consider this scenario. Now we need to find out the same scenario as the earlier for this boy to see the complete image of father. So with this as the highest head and the foot. So to see the complete image of father in the mirror, what is the minimum length of the mirror that is required? So I want you to stop here and try to analyze this situation just like we have done earlier. We will discuss this now. So the idea is to first draw the image of what you want to see, right? So the boy has to see the image of father. So I will first draw the image of father in this case at a distance of 3 meters. So 3 meters would be like this, at this roughly over here. So this is where the image of father would be formed. I hope they are of same height. So let us say this is h dash and this is f dash. Now let us name this point as E, the eye level. So this boy should now see this image. So for that image to be visible, we can say that we have just discussed earlier that, so if I draw a line starting from this f dash and extend it till the eye, it means that it shows me the point on the mirror which is required for f dash to be visible to E. So what I will do is I will just draw a line between f dash and E. So so this would be the actual ray. So that would be the actual ray. So what this means is that in reality what this line indicates is that a light ray coming from the foot of the father, which would be like this, strikes the mirror at this height and reaches the eye level of the person. So instead of doing all this, what we are doing is we are directly doing the analysis with the image, which is far simpler. So and similarly, if the head has to be visible for this boy, then a light ray which is drawn from the topmost point should reach the eye level of the boy. So this is how it would look So, this light ray would reach the eye of the boy. Once again, to understand this clearly, we can say that this light ray is actually coming from the head, striking the mirror at this point and reaching the eye of the boy. So, you can now clearly see from the diagram that the extra part of the mirror is not required. So, I can actually remove that part of the mirror, or I can say that the mirror which is between these 2 points is sufficient. So, let us call those 2 points as A and B. So, the mirror which is between A and B is sufficient for the boy to see the full image of the father. I hope that is clear from the diagram over here. So, all we need to do now is find the length of that mirror, and once again we use the concept of similar triangles. So, I hope all the points are named here. So, yeah, let us start. So, we can say EAB. So, triangle EAB and triangle EH dash F dash. Triangle EH dash F dash are similar. So, I need to find the value of AB. So, height of the father is given as 2 meters. So, even the image will also have a height of 2 meters. So, in this particular scenario, we know that this length is 1 meter, this length will once again be equal to 3 meters. So, 3 meters, right. Now, let us see here. We can write AB by H dash F dash, which means this length by this length. So, AB by H dash F dash is equal to the height of this triangle. So, the height of this triangle, which is 1, divided by height of this triangle, which is this whole length 4. So, I can write that as 1 by 4. I hope this is clear. So, now I need to find AB. I know H dash F dash. H dash F dash is basically 2 meters. So, when I write it, I will get AB is equal to 2 going to the other side will give me 1 by 2 meters. So, 1 by 2 meters is the width of the mirror that is required for the boy to be able to see the complete image of his father. So, we can actually remove this part of the mirror. So, this part is not required. Now, you may think, why is the height of the boy given in the question? Doesn't it matter? Yeah, to find the width of the mirror, the height of the boy doesn't matter. But think logically, if I give you a mirror of 1 meter or half meter width, if that half meter width of the mirror is placed at any random position, will he be able to see his father completely? No. There is a specific position where the mirror should be placed at some particular height. We can say that this is the height. So, this is the height at which the mirror should be placed. The bottom part of the mirror should be at that much height. From there, it should be 0.5 meters. So, from there this length should be 0.5 meters. You can't place that 0.5 meters width of the mirror anywhere. You can't place that here and make the boy see his father's complete image. That is not possible. So, there should be a height at which the mirror should be placed, and if I have to find that height, I need this. So, to find that height h, I will once again look at these triangles. So, I will name few points here. So, let us call this as some P. So, this point as Q, and that is anyways F dash. So, now look at this triangle. So, this is the bigger triangle and this is the smaller triangle, right. So, I will maybe write them down over here. So, the two triangles I am talking about are E P F dash and B Q F dash. So, there two are similar once again. I need to find this height, I know this height. So, I can write 0.8 by h. So, 0.8 by h is equal to, so for this bigger triangle the base length is 4 and for this triangle, the smaller one, the base length is 3. So, 4 by 3. So, 4 by 3. So, solving this 4 ones and 4 0.2s into 3 will give me 0.6 meters. So, that would be the answer for this question. So, there are two parts in this. So, clearly see them. I will write down the question as well here. So, you can note it down. So, first is the minimum length of mirror required for boy to see the full image of father, and the second one is the height at which the mirror should be placed, the height at which that mirror, which means the mirror from the first case, which that mirror should be placed. So, I hope this is clear. So, there are two parts we have discussed. First is the minimum height of the mirror required, minimum length of the mirror that is required. I have just taken the image of the father, and from the edges of that image I have just drawn two lines to the eye of the boy, and wherever it intersects with the mirror, so that part of the mirror is enough for the boy to see the image. And later on, by using some geometry, I have just found out at what height that mirror is present. So, that is the basic idea. Okay, we will discuss one more question now. So, here you can see that this is a person, this is a man who is standing in front of a mirror. That mirror is having a length or a height of 0.5 meters, and it is placed 0.3 meters above the ground. And you can see the height of the man is given as 1.5 meters, and the eye level is 10 centimeters below the topmost point, which means from the ground it is at a height of 1.4 meters. Okay, so, this is the case which is given to us. So, we need to find out how much height of man is visible to him. So, how much of his own length is visible to him in this mirror, which is randomly placed at a height of 0.3 meters. So, once again, see, we know that irrespective of the size of the mirror or the position of the mirror, the whole image will be formed behind. So, this is the first thing that you will have to keep in mind. The image which is formed behind will be the complete image, but whether we are able to see that image or not, it matters depending on at what height your eye level is or what width the mirror is. So, that is a different scenario, but remember that irrespective of the size, even if you place a very small mirror over here, the whole image will be formed behind the mirror, but you might not be able to see it. Okay. So, we know that let us consider this distance as some d, or let us also take some value for it. Let us consider that in the question it is given this value to be some 2 meters. So, let us say that length is 2 meters. Okay. Now, we know that the image is formed on the other side of the mirror also at the same distance of 2 meters. So, let us say the image is formed over here. So, this would be H dash, this would be E dash, and this would be F dash. So, if this distance is 2 meters, we can say that the image of the man is also formed at a distance of 2 meters. Now, in this particular case, you can say that the corresponding images are shown for the head, eye, and the foot of the man. Now, we will have to find out how much length of this image is visible to the man seeing from this range. So, you know that for this image to be visible, when I draw lines from this image through the mirror, it should reach the eye. So, we need to find out which part of his image will he be able to see and how much length will he be able to observe. So, what I will do is, instead of drawing the line from the image, because this is where he has to observe from, I will just look at the field of view of this person. I mean how much region or what region can he look at. So, what I am trying to say is I will draw a line from here passing through the edges, which might reach somewhere over here, and another line like this which will reach somewhere over here. So, what that means is this person's eye will be able to receive images or receive light rays striking the mirror only those which come through this region. So, if there is a light ray which starts from here, let us say which starts from here, strikes here and goes like this, that will not be visible to the man. So, only those light rays which strike the mirror and go in this direction towards that point will be visible to the man. So, we can say that whatever is behind the mirror in this region, so in this region, so this is the region of his field of view, anything in this will be visible to him. I hope this is clear. Now, you can clearly see that it looks like this is the part of the image which would be visible to the man. I think you can understand that. So, he can see even this part also, but we are concerned with how much image length of himself will he observe. So, this is the part which we are looking for. So, for this we will have to be doing the geometrical analysis here. So, let us see. So, what I will do is I will draw a horizontal line from here. So, we know that the line joining E to E dash will be a horizontal line. So, E dash will be here and H dash will be here. Okay. So, E to E dash is a horizontal line, and if I draw one more line from here, so like this. So, we know that this eye level is already at a height of 1.4 meters. So, this length is 1.4. So, if this length is 1.4, we already have 0.5 plus 0.3. So, which is 0.8. This is 0.8. This complete length is 1.4 up till here. So, which means we know this length. How much will this length be? It will be 1.4 minus 0.8, which is 0.6 meters. So, that length is 0.6 meters. Now, I will draw one more horizontal line from here. So, please observe carefully. So, I will draw one more horizontal line from here. I can say that let me mark some points here. Let us call this mirror as AB, and let us call this as P, this point as Q, this point as R. Okay. Now, you can easily understand that triangle EPA and triangle AQR. So, I am talking about these two triangles, this one and this one. So, these two triangles are congruent. The reason is you can see this angle will be same as this angle, because this line and this line are parallel to each other. So, these are just horizontal lines, this is just one single line cutting them. So, this angle and this angle are same, and similarly we know that this length is same as this length, object distance is same as image distance, right. So, those two are also equal, and this is a right angle and this is a right angle. So, based on that we can say that these two triangles EPA and AQR are congruent. So, if they are congruent, we can say that if this length is 0.6 meters, then this length here is also 0.6 meters, and we know that this is anyways 0.6 meters. We already know that this is 0.1 meters. So, now if you look at the field of view of this eye through the mirror. So, I have found the field of view of the eye through the mirror by drawing two lines like this. I have just extended these two lines further. So, which means he can see behind the mirror all those which lie in this region. So, I hope now you get an idea of how much length of his own image is in his field of view. So, this is his field of view. So, he can see anything through the mirror which is in this region, which is formed in this region. Now, how much length of his own image is in this region? So, you can easily say that that would be this length RF. And how much is that? You can just calculate it. The total length of the man is 1.5 meters, and you can see that this is 0.1, 0.6, 0.6. Totally this put together would be 1.3. So, if this whole thing is 1.3, we can say that RF dash will be 0.2 meters. So, the image length that he can see for himself will be 0.2 meters. Only 0.2 meters length will be visible for him. And they may also ask a question like this: is his foot visible to him? Is F dash, which is the image of his foot, in the field of view of the man? Yes, you can see that. So, F dash is in his field of view. So, we can say that his foot is visible to him, which means if I draw a light ray from the foot, it will definitely be able to reach the man, and you can easily guess what that light ray would be, because the foot and the eye level are at a separation of 1.4. So, which means if I draw a light ray which strikes the mirror at a height of 0.7, so if this height is 0.7, so a light ray which strikes at 0.7 will be able to reach the eye. So, in that way he will be able to see the foot. So, this light ray when extended backwards will appear to come from the foot. So, that is the idea. So, to summarize this, I can write the foot of the person is visible to him and how is the foot of the person visible to him? Through a light ray which strikes the mirror at a height of 0.7 meters from ground. So, if I consider a light ray which is striking at this point, so that is the one which is responsible for the person to see his foot or the image of foot. So, and one more thing we can say is that he can only see 0.2 meters. So, this length here is 0.2 meters. So, he can only see 0.2 meter length of his image. So, that is the basic idea. So, I want you to do this analysis by yourself, draw the basic diagram once again, do this analysis after you complete hearing this. So, try to derive this on your own once again. So, take the values 0.5 meters, 0.3 meters, the height, the eye level to be at 1.4 meters. Now that you know the idea, so do not look at the answer or do not look at the diagrams which I have drawn, try to make out the diagrams by yourself. Remember that in ray optics, only by drawing the ray diagrams or the geometrical analysis by yourself will you be able to understand better. So, watching me do it will not be able to help you. So, unless and until you put pen on paper and draw the diagrams by yourself, trace out the rays by yourself, you will not be able to get a complete idea of the particular concept. So, please do that, not just for this question, for each and every case from now onwards. So, please make sure that you do the ray diagram once you hear about the particular concept. So, that is the only way to get better at this particular topic. Students, now we will discuss about the deviation produced by a mirror when a light ray is incident on it. So, here we can say that, let me write it down. So, angle of deviation. So, it is represented with delta. So, if I consider a mirror and if light is incident on that mirror at an angle of, let us say this is normal and light is incident at an angle of I. So, this is the incident ray. So, by following laws of reflection, we can say that the reflected ray also goes at an angle which is equal to I. So, this would be the direction of reflected ray, and this angle here will also be equal to I in magnitude. Okay, so now if you see here, we can say that angle of deviation is basically the angle by which the incident ray is rotated by due to the reflection at the mirror. So if you see, the light ray is initially in this direction, but eventually it is traveling in this direction. So which means in this particular case we can say, so this was the initial direction, and this is the final direction. So the angle between the two directions, the initial and final, is what we call as deviation. That is the angle by which the light ray has deviated by. So in this case I can say delta is equal to, so we need to find out this angle. You can easily see that from the diagram itself. So this is the straight line, and this angle is I and this angle is I. So we can say that this complete angle, the deviation, will be pi minus 2i. So the whole angle is 180. So we can say that this is equal to pi minus 2i. So that is the expression for deviation produced by a plane mirror. And remember one important thing, whenever you are writing the deviation, you should always mention the sense in which the light ray has deviated by. So in this case, the light ray is initially traveling like this, and eventually it is traveling like this. So it has rotated in this sense. So you can see it is rotated in this sense. So we can say that this sense here represents the anti-clockwise sense. So whenever you are representing a deviation, always make sure that you are representing the sense as well. So AC here representing anti-clockwise sense. So that is the basic idea. So let us see a simple example based on this concept. So let us consider that there are two mirrors which are inclined like this, and let us say the angle between these two mirrors is 60 degrees. And let us consider that there is a light ray which is incident like this parallel to the base. So we can say that that light ray, after reflection from this mirror, it travels something like this, strikes this mirror, and once again gets reflected from this mirror. So we need to find out what is the net deviation experienced by this light ray after two reflections. So I will write it down. Find net deviation after reflection from each mirror. Okay. So in this case, so first let me analyze the situation here. So I have given you that this angle here is 60 degrees. So this angle here will also be 60 degrees. So if I draw a normal at this particular position, so the normal would be like this. So remember that angle of incidence is always calculated with the normal. So in this particular case, we can say this angle here will be the angle of incidence. So I, angle of incidence in this case is 30 degrees. So the light ray is incident at an angle of 30 degrees. We know that it also gets reflected at an angle of 30 degrees. So it goes and strikes like this. We can say this angle here is also 30. Now this light ray once again strikes this mirror. So to find out how much deviation it experiences here, I need to know the angle of incidence here. So I will draw one more normal at that position. So we need to find this angle. So let us do that. So here if you see, this angle is 60, this is 30, this is 30, and the total angle will be 180. So 60, 60, so this should also be 60 degrees. And we already know that this angle is 60 degrees. So 60, 60, which means this here will also be 60 degrees. Now, which tells us that this angle here will be 30 degrees. And once again it gets reflected from here, making the same angle 30 degrees, and this would be the final direction in which the light ray would travel. So this is the initial direction and this is the final direction. So in this particular case, if you see, because this angle is 30 degrees, we can say here this angle will be 60 degrees, which means this is 60 and this is 60. So this light ray, after reflection from here, it will be traveling parallel to this first mirror. So there is no more reflections that are possible. But if I change the values, maybe it is possible that this light ray might once again go and strike the first mirror. So, we will see some cases like that also, but in this case we can say that only 2 reflections are possible. Only 2 reflections are possible. Okay. So, now let us find out what is a net deviation. So, you can see that here the angle of deviation angle of incidence is 30 degrees, and we know already how to find the deviation. So, I can write delta 1 is equal to pi minus, which is 180 minus 2 times 30. So, 180 minus 2 into 30, which is equal to 120 degrees, and I have told you to represent the direction or the sense every time. So, if you see here, the light ray was initially travelling in this direction. This is the initial direction of the light ray. After reflection, it is now travelling in this direction, this way. So, which means the light ray has changed its direction from this towards left, from here to here. So, which means it has deviated in this sense. So, this is once again an anti-clockwise sense. So, anti-clockwise. Now, similarly, if I write the expression for this, so here if you see, once again the angle of incidence is 30 degrees. So, if I write delta 2, so delta 2 will once again be the same value, 120 degrees. So, check the sense once again. So, this is the direction of the incident ray for this mirror. So, this is the direction in which the light ray is, and after reflection it is deviated in this direction and travelling like this. So, you can once again say that this will also be anti-clockwise because the deviation is like this. So, this is clockwise and this is anti-clockwise. So, both are 120 degrees anti-clockwise, which means I can write net deviation is equal to 240 degrees anti-clockwise. So, that is the net deviation which we got. So, you can just leave it as 240 degrees anti-clockwise, or you can also write it in a slightly different form. So, let me just represent it here. So, if I take this as the initial direction, so 240 anti-clockwise means it would be something like this. So, in this sense, so this is the anti-clockwise sense and the value is 240 degrees. So, in this anti-clockwise sense, if the angle is 240, we can say that it is equivalent to 120 degrees in the clockwise sense. So, the same value can also be written as 120 degrees clockwise. So, that would be the expression for net deviation in this case. So, both the mirrors are inclined at 60 degrees and a light ray is incident parallelly. So, that is the idea. Okay. Now, let us see an example which involves multiple reflections. In this case, we have only considered 2 reflections are possible, that is the case. So, we will now see a case where there are more than 2 reflections that are possible. So, in this question, it is given that the 2 mirrors are inclined at an angle of 40 degrees and a light ray is incident parallel to the first mirror. So, let us name this as first mirror M1 and this one as M2. So, it strikes the mirror M2 parallel to mirror M1. So, that is the case given to us. So, we need to find out how many reflections are possible and the net deviation experienced by the light ray. So, I will first draw the normal here. So, this is how it would be. So, if this angle is 40, we can say this will also be 40, which will make this angle 50 degrees. Now, if this is 50, we can say that the light ray also gets reflected at an angle of 50 degrees from this position. So, it would be something like this. So, this will once again be 50 degrees, or let me, so this is how it would be 50 degrees. Now, so you can say that this angle here is once again 40. So, now let us look at this light ray. So, it is striking the first mirror at this particular position. So, if I draw a normal here, so we need to once again find this angle of incidence. So, that small angle which is formed. So, let us look at how much that would be. So, you can see here that this angle here is 40, this is 40 which means this complete angle in the triangle would be 100 degrees, 40 plus 40 plus 100. So, this complete angle is 100 and this is 90, which will automatically mean this angle is 10 degrees. So, angle of incidence in this particular case, the second reflection is 10 degrees. So, now this light ray will get reflected by making the same angle of 10 degrees from here and it strikes the mirror here. Okay. Now, once again we will have to find out how much is the angle of incidence here. So, I will once again draw a normal at that position and we will add the angles. So, we know this is 40 and this is 10, which will make this angle 80 degrees. So, 40 and 80 gives you 120, which means this angle here should be 60 degrees. So, if this is 60, we can say that the angle of incidence here is 30 degrees, right. So, the light ray will once again get reflected making an angle of 30 degrees in this manner, and considering that this first mirror is sufficiently long, so we can say that this light ray will eventually go and strike mirror 1 and get reflected from here. So, once again we need to find out what is the angle here. So, let us see, this is 40, 60, 30, 30. So, 60, 30, 30 will give you 120 as a whole here. This whole angle is 120 plus 40 is 160. So, which means in this bigger triangle which is formed, this angle here should be 20 degrees, which will automatically mean here this angle will also be 20 degrees and the light ray gets reflected in this direction. So, one important thing which you can see here is this light ray is definitely not going to strike this mirror once again. Even if you consider that this mirror is sufficiently long, infinitely long, this light ray is not going to strike this mirror, and the reason is the angle at which it is going. You can see here that this mirror is making an angle of 40 degrees with the horizontal, whereas that final ray is making less than 40, it is going away like this at lesser angle. For that light ray to strike this mirror once again, the angle should be more than 40, so that it can go and strike somewhere at some other distance. But because this is having greater angle and the light ray is having lesser angle, it just goes off, it is not going to meet this mirror once again. So, that is the basic idea. So, this is the final direction in which the light ray goes. So, to find the net deviation, you can take each individual deviation first, each individual reflection, find the deviation here, 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 here and add all the 4 according to the senses, which is what I would want you to do. I will directly write the deviation by looking at the initial direction of the light ray and final direction of the light ray. I want you to verify that result by writing deviation for each individual case and then adding them according to the senses. So, please do that. So, I will directly write the answer for this by looking at the initial direction, which is in this way, horizontally towards left, and the final direction is like this, making an angle of 20 degrees with horizontal, right. So, this is initial and this is final. So, we can clearly say that this is the deviation. So, which means the value should be equal to 180 minus 20, which is 160 degrees clockwise. So, that is the idea. So, please do that, write all individual deviations at the 4 reflections, add them and check whether you are getting this result or not. Okay, now let us consider a situation where there is an incident ray which is getting reflected from a mirror. Now, if I change the direction in which the incident ray is being incident, we know that the reflected ray's direction will also change. So, that is what we are going to discuss now. If I change the direction of the incident ray or the plane of the mirror, so as the light ray is getting incident, so if I just change the orientation of the mirror from here to this orientation or something like this. So, if I change the orientations of the incident ray and the mirror, how will that affect the final reflected ray. So, let us start with changing the direction of incident ray. So, this is the normal. So, considering that the incident ray is like this, making an angle of theta. We know that the reflected ray will be like this, also making an angle theta. So, this is incident ray, reflected ray. So, now let us consider that the incident ray which is like this, I have rotated this by some small angle or some angle. So, I have rotated it like this, let us consider. So, which means I have changed the direction of the incident ray like this. So, this is my new incident ray. And let us consider that it is rotated by an angle alpha. So, we can say that now as I rotate the incident ray's direction, so you can see that the new angle of incidence for this incident ray would be theta plus alpha with the normal. So, you can say that this is the new angle of incidence. So, which will automatically mean that the new reflected ray will also change its direction and it would now be like this. So, this would be the new reflected ray, and once again you can say that this angle should be alpha, because with the normal it should be also making an angle of theta plus alpha. So, one important thing which you will have to observe here is that the incident ray I have rotated it like this. Now, you all know that this is the sense in which the incident ray is rotated. From here it is rotated like this. Now, if you look at the reflected ray has rotated in this sense, or in fact the opposite. So, from this direction the reflected ray has rotated like this. So, which means it has rotated in this sense. So, from here this is the old incident ray, this is the new incident ray. So, it has rotated like this. So, this is the sense. So, you can see that the sense of rotation of the incident ray and the reflected ray are opposite. This is, if this is anti-clockwise, this is clockwise. So, that is the thing which you will have to understand from here. If the incident ray is rotated by an angle theta, then reflected ray also rotates by theta, but in opposite sense, So, that is what you will have to understand here. Now, moving on, so let us now see what kind of effect does the deviation, what kind of effect will occur in deviation when I change the orientation of the mirror. Instead of rotating the incident ray, if I change the orientation of the mirror, let us see what will happen. So, once again here I will consider that the mirror is like this. This is the normal. Okay. So, I am not going to change the incident ray's direction in this case. Incident ray will always be in the same direction which I have represented. So, let us consider this as theta. I am going to change the orientation of the mirror itself. So, this is the plane of the mirror now. I will just, let us say, rotate like this by some angle. So, let me draw the initial incident reflected ray as well, which would be like this. So, this is reflected ray and incident ray. Okay. So, now I will change the direction. So, let us consider that the mirror is now like this. So, I have rotated the mirror. So, this is the new orientation of the mirror, right. So, let us consider that the mirror has rotated by an angle of alpha in the clockwise sense. So, it has been rotated from this orientation like this. So, this is clockwise. So, the new because of the rotating of mirror, we can say that the normal to the mirror also rotates. So, this will be the new normal which I am drawing here. So, the black dotted line is the old normal for the old orientation of the mirror, and the blue dotted line is the new orientation of, the normal to the new orientation of the mirror. So, let us call this as N as well. So, this is old normal, this is new normal. Now, remember that I am not changing the direction of incident ray, I am just changing the direction of normal. So, if you see here, because this angle is alpha, this angle can also be taken as alpha. Now, because of rotating the mirror, you can clearly observe that the net incidence angle has changed. So, what is the angle of incidence now? So, now the angle of incidence is, you can see here, theta plus alpha. We are now measuring it with the new normal. So, that is theta plus alpha. So, which means the reflected ray should also be making an angle of theta plus alpha with the new normal. So, if I consider that the reflected ray this time is something like this. So, let us say this is the final reflected ray. So, we can say that it should be making an angle with the new normal. So, I am drawing the angle from the new normal, and this complete angle here should be equal to theta plus alpha. I hope this is clear. So, the incident ray is making an angle of theta plus alpha with the new normal, which means the reflected ray should also make theta plus alpha with the new normal. So, that is the idea. So, now we are concerned about how much deviation has occurred in the reflected ray. So, this is the reflected ray initially, this is the reflected ray finally. So, I am looking for this, and this is the sense in which it has deviated like this, and let us consider that this deviation, let me represent this as some delta. So, let us call that as delta. Now, we need to just measure the value of delta. So, see that how do we measure that delta value. So, we can say that this complete angle is theta plus alpha, right, and this angle is alpha, which means we can say that this angle from the old normal to the final reflected ray, we can say that this angle will be theta plus 2 alpha. So, this is theta plus alpha plus alpha. So, this angle will be theta plus 2 alpha. Clear? Now, we also know that this angle is theta. How do we know that? Because that is the angle between the initial reflected ray and the initial normal, which is equal to the initial angle of incidence. So, because this is theta, we can say that this is also theta, and we have just seen that this complete angle is theta plus 2 alpha, and this is theta. So, which means this angle should be 2 alpha. So, that would be the deviation which we would be getting in this case. The value of delta will be 2 alpha. I will quickly repeat once again, please observe here. So, because this is theta, this angle is also theta, and because of rotating the mirror by an angle alpha, the normal has rotated by alpha, and because normal has rotated, we can say that the new angle of incidence between this light ray and the new normal is theta plus alpha. So, the final reflected ray also makes theta plus alpha with the new normal. So, now based on the angles which are formed over there, so we get the final value of deviation as 2 alpha for the reflected ray. So, please go through this once again, try to draw this diagram again by your own, and try to find out each and every angle which is formed over there. So, you can easily understand that. Now, one important thing which you will have to observe here is that the mirror, you can see that the mirror is rotated in this sense, clockwise sense, by an angle of alpha, and you are observing that the reflected ray also rotated in the clockwise sense by an angle of 2 alpha. So, that is the result here. If the mirror rotates by an angle alpha, then the reflected ray also rotates, or then the reflected ray rotates by an angle 2 alpha in the same sense. So, that is the idea here. So, in whichever sense you have rotated the mirror, the reflected ray rotates in the same sense by double that angle. So, that is the case. So, please go through this again, try to find out these angles and derive this result on your own. So, you can do that by drawing a clear diagram.